All right, number 7 says find exact answers for interval 0 to 2 pi for this trig function. All right, 0 to 2 pi means it would be first quadrant, second quadrant, third quadrant, fourth quadrant, all the way around. Right. So when you get a question like this, tan of x equals -1 over root 3. Right. The thing is, this negative kind of hanging out in the front, this negative could go either. Come on. It could go with the numerator or it could go with the denominator. Right, but it can't be both, because if it's both negative, then your negative divided by negative would be positive. Right. So that means that we can either say tan of x is -1 over root 3, or tangent of x is equal to 1 over root 3 with a negative there. All right. So if tangent is negative, remember the tangent is opposite over adjacent. Right. So the opposite side would either be -1 with an adjacent side of +3. So if you kind of sketch that, right, opposite side being negative, remember the opposite side is the y, and then the adjacent side is the x. So we want a negative y value, but a positive x value. So that would go in the fourth quadrant. Right. Opposite side would be -1, the adjacent side would be root 3. Right. So that would be this first version right here. Let me just move this over. Right. Now, if it's flipped, if we have the opposite side is positive and the adjacent side's negative, and again, this is y over x, we want a positive y value but a negative x, so that would make it in the second quadrant, like so. Right. So this would be a negative root 3 and a positive 1. All right. So another thing that we did way back is the 30, 60, 90 triangle. Right. The 30, 60, 90 triangle looks like this. If you have a 30-degree angle, 60-degree angle, right? Opposite of 30 would be 1. Opposite of 60 would be root 3. And opposite of 2 is the 90-degree angle. Right. So what we want to do is kind of focus, right? We have the adjacent side being root 3. So the adjacent side being root 3 would mean that this angle is 30 degrees. Right. So if the adjacent side is 3, the opposite side is 1 or -1, right? Depending on how you flip the triangle. That forces this angle right here to be 30 degrees. Right? Because we have this special relationship between 30, 60, 90 degrees having the opposite adjacent and hypotenuse being these numbers. On the flip side here, right, we have a 1 being opposite of this angle. Opposite of that angle would be 30 degrees as well. Right. So we have these interior angles. All right. So the question here is, what is the x value? Well, in this case, x is in quadrant 4. In this case, x is in quadrant 2. Right. And remember, the way this works is it rotates from the x-axis and going this way. Right. So if this is 30 degrees, the angle I'm looking for in this case, x would be 360 degrees minus 30 degrees, right, which would be 330 degrees. All right, so kind of just backtracking here, the first thing I did was, using my given information, I kind of analyzed what is the ratio going to be, right? We need to figure out, where does the negative go? Well, the negative in this case either goes with the numerator or the denominator. If it went with the numerator, we're going to be in the fourth quadrant because the opposite side is negative, the adjacent side is positive. And if it's in this, if the negative is with the denominator, then the opposite side is positive, then the adjacent side is negative, right? So we figured out from the special 30, 60, 90 triangle that this is going to be 30 degrees in the interior, but my angle's in the exterior, right? My first angle in the fourth quadrant is this right here. And I know that if I add up that angle, or if I take 360 minus 30, that gets me the angle I want. On the flip side here, this is my angle in the second quadrant. Right. In this case, I know that x will be 180 degrees, which would be a full rotation. Take away the 30 degrees on the inside. So this would be 150 degrees. All right. And if I were to type this into Weberstein, it's going to mark me wrong because these angles are in degrees. And they tell you that the interval is in radian mode. Right. So if you've got an interval in radian mode, you need to have your answers in radian mode. So my two answers in this case, x equals 330. Remember, to convert the degrees to radians, what you do is you multiply by 180 pi, upside down. Multiply by pi radians over 180 degrees, right? So the degree symbols are going to cancel out. If you take 330 divided by 180, right? I'm just looking at the numeric values here. If you do 330 over 180 in your calculator, and then hit the convert button. Right, remember the convert button looks like this. So if you did 330 divided by 180, then the convert button tells you that's 11 over 6. So this answer is 11 pi over 6. Right, if I just looked at these, that's 11 over 6. Don't forget you still have the pi. And then if x is equal to 150, right, same thing here. We're going to multiply by pi over 180. All right, if you want to reduce this, you just take the fractional part, 150 divided by 180, and then do the convert button. You get a 5 pi over 6. Right, so these are my two answers right here. Right, these are correct if it didn't care which mode you're in, but it did specify radian mode right here. So you want to answer your radian answers. All right, so steps for this problem. The first step is to figure out which quadrant you're in. Next step is to label the side lengths, right? The opposite over adjacent. You go to the 30, 60, 90 triangle and see what matches to figure out that interior angle. And then from there, you can kind of figure out the outside angle. Right. Number 8 is going to be done the same way. So I'm going to start by figuring out, well, where does the negative go? Right. Also, I like working with sine, cosine, and tangent. So instead of using cotangent, I'm just going to say, well, let's take the reciprocal of this. Tangent of x is equal to just root 3 over 1. Right. And remember that negative can go either with the numerator or the denominator. All right, so we've kind of done this problem already, so I'm going to work through this. All right, remember that tangent is opposite over adjacent. All right, so the opposite side, if it's negative, would be in quadrant 4. Right, opposite side here is negative root 3. Adjacent side is 1. And then on the other side here, right, if the opposite side is positive, the adjacent side is negative, it gives me this. All right, so going back to the 30, 60, 90 triangle, I'm going to draw it right here. Right, so we've got the angle is right here, so we need to figure out which angle that is, right? So we've got root 3, and then we've got the opposite angle here. So root 3, opposite angle would be 60 degrees. And then same thing here, right? If we have the adjacent side is 1, we've got 60 degrees on the inside as well. All right, so this turns out to be the same two angles that we were just working on, right? This is 330 degrees and then 150 degrees. Of course, your numbers might be slightly different, so just adjust accordingly. 330 degrees here. This is 150 degrees here. So my x values, we said 330 degrees was 11 pi over 6. And then 150 is 5 pi over 6. So this turns out being the same triangles. If it's not, then you adjust accordingly, right? If your angle is a little different, right? So again, so same steps here. First is figure out which quadrant you're in by looking at the ratios. You might have to adjust where the negative goes. Right. From there, you can use the 30, 60, 90 triangle. Right, you might have to do it to 45 to see if we have any examples like that. Right, figure out what your outside angle is, your exterior angle. Right, that's 330. This one was 150. And then you want to convert them into radian mode. All right. Let's look at number 9. Number 9 is going to be a little different. All right, this time it's secant. In this case, it is a positive value. And again, I don't like working with secant, cosecant, because there's no secant, cosecant button in the calculator. I'm just going to take the reciprocal of this. Cosine of x is root 3 over 2. Right, and remember that cosine is adjacent over hypotenuse. Right. So the thing here is, remember that the hypotenuse has to be positive, right? Which means adjacent has to be positive. Positive divided by positive. Right. So this is going to happen at 2 separate places, right? The adjacent side could be positive in the first quadrant, but it can also be positive in the fourth quadrant, as we've seen in examples, right? Adjacent side being root 3. Could be in quadrant 1, it could be quadrant 4. Hypotenuse is still 2. Right, so we just need to figure out what the angle is on the inside. All right, so again, we're going to refer back to the 30, 60, 90 triangle. All right, 30 degrees right here, 60 right here. Right, remember, opposite side of 30 is 1, opposite of the 90 degrees is 2, root 3 right here. So what we have is that root 3 is the adjacent side. So in this case, this will be a 30-degree angle on the inside. All right. So my reference angle is 30 degrees this time. The reason being is that we're given the adjacent side is root 3. So we're going to follow that angle right here. Right. Well, we've done this a few times now. This angle is 330 degrees. The angle, remember, starts on the x-axis, and rotates. So this happens to also be 30 degrees right here. Right, so this gives me my 2 answers, one in the first quadrant, one in the fourth quadrant. Right, we've done this a few times already, so I'm just gonna shortcut this. And then 30 degrees is just pi over 6. All right, so for questions like this, you have to give all the correct answers and no incorrect answers. There's no partial credit here. You either have both of them in your answer box, or if you don't, then you're not going to get the credit. All right, no extras, no missing anything. Right, you make sure you have both answers there. All right, so again, place your quadrant. The adjacent side being positive means that it could be quadrant 1 or quadrant 4, because the x values are positive in that region. For a lot of these questions, you're going to end up with 2 different triangles. So just make sure that you're aware that there's probably a second triangle that you have to deal with. All right, so number 10 is going to be done the same way. You're going to have a cosecant question. Figure out your quadrants, right? If you need to use it, there's also the 45, 45, 90 ratio. All right, the ratio there is 1, 1, root 2. So the giveaway there is if you have a root 2 in your work, then you might have to use the 45, 45. So these are your 2 special triangles, which we introduced back in section 5.2. Or maybe 5.4, I don't remember now. All right, I have one more question that I want to deal with, and then we're going to do the rest of the content, starting with number 12 on Tuesday. Right, this is what's called a quadratic, a trig quadratic, right? It looks like something squared plus something minus 4. So what I'm going to do is I'm going to pretend, let's say y equals cos x. So what's going to happen is this is the same thing as 6y squared plus 5y minus 4 equals 0, right? So you end up with a quadratic. All right, what we can do is you can either factor it or use the quadratic formula. Right, so I think this factors. Let's see if I can find it. Think of, maybe it's a 6. Think of 4 here and a 1 here. No, that doesn't work. 4 here and a 1 here. There we go, right? So a plus and a minus here, right? So 3y squared, or 3 times 2 is 6y squared. That looks good. Negative 3y plus 8y gives me a 5y, and then minus 4. Right, so you can either, again, factor, or if you don't see how it factors, go ahead and jump to the quadratic formula. Right, so that means that 3y plus 4 equals 0, or 2y minus 1 equals 0. All right, so you get either y equals 1/2, y equals negative 4 over 3. All right, so this is the quadratic part of this question, right? So what we started with was a cosine function. We did a little substitution to make it into a quadratic so I can factor, right? So once we factored, we set each component factor equal to 0, giving me 2 answers for y. But remember, we're solving for x. So what I'm going to do is I'm going to backtrack and say, well, y is actually cosine of x. So now this becomes like the questions that we were doing just now. Right? Remember that cosine is adjacent over hypotenuse. Right? And of course, adjacent can't be bigger than the hypotenuse, right? This negative is irrelevant, but we can't have the hypotenuse being smaller than adjacent, so this is not possible. Right? If it was 3/4, then we could do it because 3 is smaller than 4. This one is okay, right? Adjacent is 1. Hypotenuse is positive 2, right? So if the adjacent side is positive, then we can be in 2 different quadrants. So just like the previous questions, we're going to have 2 different triangles to deal with. Right? So adjacent side being 1, hypotenuse being 2. Right? And then if we let x be positive 1, the adjacent side being 2, we could also be in the 4th quadrant. Right? Adjacent meaning positive 1 right here, and then hypotenuse being 2. So going back to this 30, 60, 90 triangle. Right, so in this case, the adjacent side is 1, right? This angle is touching the side length 1. That means that this angle will be 30 degrees. We didn't do any 60 degrees. That's so weird. All right, so well, we've done this problem before, but again, if you have a different ratio, please make sure to have the correct side lengths. So this is pi over 6 here, and this is 11 pi over 6. This one showed up a lot. All right, so this is all I have for today. If you guys have any questions, feel free to stick around. If you have any questions on the homework step due tomorrow, this would be a good opportunity. Otherwise, you guys have earned your attendance credit. Thank you for joining me on this Thursday afternoon.